My name is Felipe Pires, and today we're going to talk about discovering CNC in Malicious PDF, right? So this is my contact at Twitter, at Felipe Pires, and here some information about me. We can find other talks that I've been talking in different events in felipePires.com, and my GitHub here you can find other projects and articles that have been published there, and my LinkedIn as well. So if you'd like to exchange something with me, so I really appreciate that, okay? So who am I? I'm a security researcher at Sapporo. Sapporo is a company from Switzerland, and I'm responsible for creating the intelligence behind of this project. Basically, I'm responsible for creating different attack modules for the attacker perspective, and I create this logical of these attacks based on cloud, on-premise environment, and I send those information to the development team, and this team is responsible for creating intelligence for this specifically product. So the idea of this product is to working with the specific cyber resistance and to give this information for our customers, okay? And I'm security advocate at Senha Segura. Senha Segura, it's a company, a global company responsible for provide different PAN solutions. PAN, it's acronym of the privileged access management, right? And I'm advocate of this awesome project called Hacking is Not a Crime. Basically, the idea behind of this project is to talk about this concept called hacking, because hacking is really the kind of lifestyle that you can use in your life. Not only, of course, we are talking about security, about the technology, but how you can use your creative mind, how you can implementing this not only in software but in your life. Okay, so that's the idea. Because when let's suppose that you are a lawyer, if you executing bad things, in this moment you are a criminal and not a bad lawyer, right? So that's the difference. So when you see something like specifically leaks of the informations or some company that have some data exposed, basically this is about the cyber criminals, not a hacking. Hacking, it's a mindset and how we can use this. This is project started in the US, but we have advocates, around the world. Okay, and I'm a SNIC ambassador based in this specifically open source project. The idea of the SNIC, probably you know about that. So it's a SaaS solution, well, not only SaaS solution, but the idea behind of this technology is to talk about the secure development process basically. So when you create a specifically app or code, so how you can create this in a safe way or a security way. So how you can give this acknowledgement or these things to the developer team, okay? And I'm a lead of the DCG 5511. It's basically in a small group, a small community in Brazil, in São Paulo, as part of the DevCon groups. And I'm instructor and writer and reviewer those 3 magazines here in Europe. By the way, I'm Brazilian. I'm talking from Portugal because I'm living here now. And let's talk about our main topic today. So what is exactly a threat? Before to talk about our main topic today, it's pretty important to put all those people on the same page. So it's a simple definition, what is a threat? Because when you're looking from the specifically investigation, analysis, and stuff like that, we need to understand first what is exactly a threat, because you don't know if it's malicious or not, or you have a sample, you have a specifically artifact, but you need to investigate more of that. So what is a threat? Basically, according to this ISO, is a potential cause of the specific incident, may cause harm in the system or organization. But what kind of a specific incident or causally, in this case, is a software attack, theft of intellectual property, identity theft, sabotage, and information distortion are example of information security threats. So if you see here, many of those things that I'm talking now is about the software. So if you think about software, first you have a code. So basically a threat, it means is a possible or potential, in this case, a potential incident, but all those things is related to it specifically in a software. It's pretty interesting. And basically, this is the definition from this ISO. It's not a Philippe definition, but this specifically ISO, okay? So first of all, when you have a specifically artifact or a sample, you need to go to this specifically step. The first step is identification step, because you don't know if it's malicious or not. You have a specifically, you can have in the future, when you execute these investigations, you can have a malware, is an acronym of the malicious software, or you can have a maldoc, and a malicious document is another contraction, let's say this way, okay? So you can investigate that. Of course, you can use in different methodology to use in this specific analysis. Those methodologies called the analysis static or statistical analysis and dynamic analysis, based on those 2 methodologies. Maybe you are thinking about the reverse engineer. If you don't know, basically it's a technique using in even those specifically methodology, okay? It's more deeply, of course, into looking from the assembly stuff like that and other things like this. Okay, so when you perform a specific analysis, my recommendation to you is always you're writing those things, right? Why you need to do that? Because when you write this in something like this, you can learn more about that. And not only that, but you can understand how the attacker is using different techniques to bypassing different security sensors. And other thing that you can use when you write those things is to create a specific report. In this report, you can present your manager, your coordinator. It's very interesting because you can improve this. You can improve your defenses mechanism. It's other point important because when you understand about all those steps performed by the attacker, you can understand what techniques used by these attackers, and specifically, I don't know, firewall, APS, or IPS, or antivirals, or IDR, or other solution that you have in your environment. You can understand exactly the technique used by the attacker, and you can improve your security defenses mechanism. And you can provide any specific information for a cyber threat intelligence team. And if you don't have this in your organization, you can create that, of course. And you need to not only understand that, but you need to have this specifically training in cyber resilience, because the threats are changing all the time. So, okay, so we have a sample, we have a specifically artifact that you need to investigate. Okay, so after that, what the steps? So if you see here, first identification, after that, you can choose what the best methodology you can apply, statistical analysis or dynamic analysis. So what does that mean, Philippe, in this case? Statistical analysis, basically simple definition, usually is the first step used in the malware studies. Why? Because this process describes the analysis of the program code or the structure to determine specifically function. Let me explain more thing about that. So if you have a specifically DLL or a specific library inside of your system operation, this library is responsible for call and specific or using specifically function in your system operation, or all those things is necessary to run a specific binary. So when you analyze more deeply about that, you can understand all those program code, you can structure those informations, and you can move more deeply in this case. But the program itself doesn't run at this time. That's the idea behind of the statistical analysis. So in this case, it's make this process more safe. Okay. On the other hand, you have a dynamic analysis, another different approach, and a different methodology that you can apply. And this case is based solely on behavior. In this case, the interaction that the malware or the sample or artifact has when it's executed in your environment or in your lab. Basically, in this case, the analysis in a runtime. So if you see, two different approach in a runtime analysis, another is a no runtime analysis. Okay, and of course you can automate this methodology. Basically, you can use in this, and one of this concept is called sandbox. When you have a specifically controlled environment, you can execute your sample inside of this, and you can see those behavior. But take a look at this. Pay attention to this. When you have in a sandbox, you have a virtual machine. Inside of this virtual machine, you have a different engines. You need to have these engines inside of your sandbox. Why? Because when these engines will be responsible for give you the result of this specifically behavior inside of your environment. Okay. So of course you have a different sandbox, open source, like a Cuckoo, like others, or you have another online cloud sandbox or antivirus scan like a VirusTotal, for example, or Hybrid Cloud or Joy Sandbox and others to execute your sample inside of this and understand if this behavior is malicious or not. Okay, so before to talk about the physical and logical structure of the PDF, I would like to explain something about more idea about the identification steps, so how important it is to understand those things. So I have here, and specifically two artifacts here. I have a regex.python and sample.python, two files that I have here in my virtual machine. Okay, so first of all, let me check what is exactly this file. So if you see here, I have here in a Python script. Okay, it's a text file, but in this case, it's executable. So let me read and more. Let me execute this. No, I will not execute, but I will read this information. In this case, as you can see here, the being Python, I have this information here, the UTF codes, the encoding responsible for this. If you see here, removing special characters for a string by regex. It's a simple Python code responsible for removing the stringings for a specific regex, as you can see here, okay? And I will send all those information for a specifically set underscore dump.text. So I will execute this Python. I will removing special characters and send you for this specifically file. It's a Python code, okay? So if I try see here, another is a PDF sample version 1.7. You can see here, and zip the flat encoded. Probably I need to execute something to decode here, probably. But let me show you something about how you need to understand about those identification steps. Okay, so remember we have here two different files. Okay, regex.python and sample.pdf. So if I execute here PDF ID, it's a very interesting tool from DJ Steven. If you see here, a simple tools to looking from more information about the PDF in these cases. And if you see here, I can see the header informations about the specifically version, the quantity of the objects, the streaming, and other things. So I will talk more about those steps in after, okay? But pay attention on this here. So how, in this case, how the file works in this case, because I'm looking here and then identify this file has a PDF script, but existing one information pretty important that file using to collect those information to identify that. So take a look at this. What is a file? In this case is a specifically tool that determine a file type. Okay, understand that, but what is exactly information that you can see or you can use when you execute the file command. Here is the information based on the manual. Probably you don't like to read the manual. I don't like to, but we need, take a look at this. This file have a magic number stored in a particular place near the beginning. So basically file using a specifically database to collect those magic numbers here. And based on this magic number that you can find in the inside of this database from file, they will identify what is exactly the file type. Let me explain more details about that. So let me using here sudo nano, yeah, this is my editor text, sorry about that. So if you are frustrated, but anyway, so let me go there and I will put in here, I will change something here. So let me put in there, take a look, this %pdf dash 1.7. Let me save here, take a look this, I save here. And now take a look what happened in my specifically file. Wow, we have a PDF document version 1.7. You see? So if I try to read again, take a look at this. I just changed one information here, but in this case, this information is based on, this is a magic number of the PDF file. So if I'm using here PDF ID, once again, and I put regex.python, take a look, this is the extension. It's not, this tools checks not based on extension, but based on the magic number. If I try executing here, take a look, this is the identification of the header and how many objects this PDF have. In this case, 0. Don't have any streams and other information, but it's really a PDF. Even the workstation doesn't appear as a .python. You see? So, but if I return here once again and I cut this and save once again, take a look what happened. File regex, and now I have a Python once again. But let me move once again for regex.python. But I change for a PDF. So now take a look what happened. I have two PDF files. File regex.python, continue be a Python script. If I try using PDF ID once again, but now it's a PDF. In this case, take a look. This is not a PDF document. Why? Because the magic number is a Python script, not a PDF. You see? So it's very important you understand how you can or how you will use your tools in your environment, because based on these tools, you can receive specifically results, right? So when you're using some tools to help in, for example, for reverse engineer is the same case. We receive a specifically response from these tools. When you perform some command, we receive some results about that. And that's the point here. So we need to understand those bases. When you understand that, you can move in for the next steps. Okay, returning here from the presentation. So let's understand something about the structure of the PDF. So we have our header, you have a body, you have a cross-reference table or X table, and you have a trailer responsible for identify some information inside of this PDF, basically. Okay, so if you see here, first we have a version. In this case, a version inside of the header. Remember, 1.7 when I execute the tools. Okay, inside of the body we have a page, image, font, and stuff like that. This is a shining thing inside of the PDF, and the important information you can find here in the X table. I mean, in the cross-reference table, it's a location of this object within the file for random access. I mean, basically, you have a specifically root file. First one, you have a specifically two tiles, the object 2 and object 3. And you can have another, like, for example, in object 2, can have another different object, like a 3, 4, and 5. Like at 3, you can see you have a root in the middle, in the beginning, you have another extension of all those objects. So because of that, it's very important you understand those flows inside of the PDF file, okay? And the trailer is a part of this access of the certain object inside of the body, okay? All those, if you see here in the PDF structure, all those objects are connected, okay? So let me show this specifically demonstration that I recorded because we don't have a time to executing all those steps. Because of that, I recorded, but I will explain more about that. So I receive in a CVE, basically a resume, okay, in PDF. So first I check if this PDF was really a PDF document. In this case, it was. And of course, I looking from more details about the structure to understand that. And if you see here, they have 15 objects, as you can see here, right? And other information that you can find here, it's about the streaming. In this case, they have a 2 streaming. Usually when you see the streaming is it's a good opportunity that attacker is using to put in malicious things inside of this stream. So of course, you can see other parts of this, all the other structure of the object, but the streaming is a very good part that threat actors or attackers, whatever name you want, less hacker, okay, you can find malicious informations, okay? So, and other thing that you have here is JavaScript. So we have a 5 JavaScript or 5 reference of JavaScript. So maybe something is not common when you find this in a PDF. Okay. So first of all, I execute in PDF parsers, another tool from DDA Steven. Okay. So we can using some commands like -s to search for specifically informations or something like this. So first I try just to confirm where is exactly the place that you can find the JavaScript. So we have a first reference object 1, other reference is object 7, and object 12. 3 reference of a JavaScript. Remember that 3 reference. Another is JS, the second one. So if you see here, object 1 and object 12, 2 others reference. So if you see, make totally sense. So first I use executing PDF ID. So I perform this specifically scan to check the strings. And after that, I execute a PDF parser to looking more deeply about that. Okay. The second command that I used in this specific investigation, it was -w in this case. That means the run output for data and filters, because my idea here was open the run data inside of this PDF. So take a look at this. First, we have an object 1. This is the first. Remember the 3, okay? And if you see here, we have 6 reference. 2, 3, 4, 5, 6, and 7. Thinking about the 3, okay? And in the middle, we have specifically object 1 and 6 other informations behind of this object one. Remember, the child object, okay? And we have here some open actions and JavaScript. So Felipe, what that means in this case, open actions? So I will explain more about that. So take a look this behind, you see the open actions. In this case, the open action is a functions inside of this PDF. What is this open action is responsible? Basically, if you working in a specifically HR team, you probably receive resume or CV a lot. If you work in a financial team, probably you receive many invoices per day, okay? So it's a normal behavior. We will open the PDF because you receive these informations, okay? Okay, so let's suppose that you are these people and you will open this file. So when you open this is the only click that you need to execute in this PDF. You receive a resume from your candidate email, okay? And you receive this, you click, you will open this PDF. This is the first actions that you not only first, but the only action that you need to execute. After these actions, we will executing and specifically automatically open actions. Why? Because in this PDF has this function. So after the user open the document, will be executed something in the background. Why? I don't know. We need to investigate. But this action is totally linked with the specifically JavaScript, as you can see here. So in the part of this block, of this not block, but this a part of this document. In this case, this open action is totally linked with this JavaScript. So what that means in this case, when the user receives the document and click in the PDF, JavaScript will be executed in the victim machine. What is the result? I don't know. We don't know. So let's move on in this investigation to understand that. So we already understand this process, open action and JavaScript. Let's continue to see. Here some information, but and these tools probably don't have the mechanism to open these information. Object 2, nothing, 3, nothing. Object 4, we have another 2 reference, 8 and 9. Remember those 3, the 3, remember that? Object 1, other reference, okay? Other child per object, okay? Nice. Object 7, reference object 10. Here, some informations about the JavaScript, some reference, object 80, format, images, stuff like that, not value information here, and reference, again, one of those child's reference itself, okay? In object 10, we have another object 12. Maybe you have here the JavaScript. And take a look at this. Here in object 1, we have the first streaming. In this case, as you can see in object 11, we can see the contain streaming and have a specifically filter. In this case, the filter or the information inside of this stream has a specifically left. In this case is 36, and they have the code tag. I mean, in this case, I need to decode this information inside of this specifically streaming. And another point here is the left. In this case, the size is not too big. It's 36. It's a small size. Okay, but maybe you can look in from the object 11. In object 12, we have another reference, object 13, and maybe let's see here. In object 13, we have the second streaming. Remember, we have 2 streaming. In this case, the left is too big when you compare with the first. Okay, so maybe this is should be the main object to investigate, because the left is high. It's not high. It's big, and you have here the streaming. Okay, if you remember, they probably have a specifically JavaScript here, because here is the reference, object 12. Remember the child? So basically object 13 is a child of the object 12. Okay, so let's move on. We had 15 objects, remember that. So here object 12, I mean the 14, and another is 15. Okay, so let's move on for the another tools. So if I need to looking from the streaming, probably I need to using other tools that I can extract the streaming information. And in this case, I execute the PDFTK, because when you're using PDFTK, you can compress those information inside of this specifically streaming, not only compress, but you can uncompress the information. So that's my idea. If I can compress, I can uncompress, right? Or recompress. You can execute in different things using these tools. And or you can merge PDF as well. So in this case, I execute PDFTK, I set the document, and I request what? I request this output, and this output, I request the uncompressed information, as you can see here, right? So if you see here, I have the dump, so I can investigate more information about that. So when I try to looking from the dump informations, take a look what I found in object 13. I have here the JavaScript, the raw data of the JavaScript. In this case, this JavaScript are using a specific technique. This JavaScript is obfuscated. So this is the first technique used by the attacker. So the next steps, I need to disobfuscate this JavaScript. So first of all, I copy this code and paste here to understand all those informations. And if you see here, take a look at this, I have here some evil parameters. And I thought when I performed this specific investigation, so I was looking from the specifically JavaScript, maybe I can looking from the HTML file, or I can try to read this in a specifically web page. That's my thought when I performed this investigation. So I using this specific evil parameter to rewrite this document. Because of that, I put in this specifically tag of this parameter actually from HTML. So if you see here, then my idea is to using this. And if you see here, take a look this standard behavior. If you see here, ladder percent number, ladder percentage number. It's very, very interesting behavior, not behavior, but the standard, the pattern, actually the pattern of this information. So I rewrite this file, I created a specific file and that I call it sample, and I give the permission to execute itself in a specific browser to open those information to understand what that means. In this case, it is JavaScript obfuscated. So I disobfuscated this code and take a look what I found. In this case, I execute this and wow, we have here a specifically payloads. You know what that means? Payload is the package or a code responsible for download this in the victim machine. And this package, this piece of package is responsible for performing the callback of the commanding controller from the attacker. So I found the JavaScript obfuscated, and after that I found the payload. So if I found the payload, I can move on and investigate more about that to try find specifically the CNC from the attacker. So after that, I executing some investigations in Unix platform. But if you think Philippe just using the Unix, I using Linux as well. Let me show you here. Let's move on. Yeah, I copy here the same payload as you can see here. I copy this and I using other platform in the Windows environment. So if you see here, I using Mozilla to collect this information. So first of all, I pass here, as you can see, because in this case, the attacker using another technique, basically the Unicode technique based on 2 different bytes, because you can use it, for example, an ASCII or Unicode. ASCII is based on 1 byte and Unicode is based on 2 bytes. And the attacker using this specifically encoding techniques here, but it's kind of old because the attacker using the UCS2, as you can see here below. This is an encoding technique, so I need to decode this and convert this in an hexadecimal file, as you can see here. I will click here, and after that, I have then specifically hexa file payload, okay? After that, I generate a specifically binary. Why do that, Philippe? Because the binary is responsible for executing in the Windows platform, right? So basically, this is the format of the attack, okay? So creating this file, cnc docbin, and after that, I using short to try maybe to try find some information about the HTTP inside of this binary. And if you see here using short search, other tool from DDA Stevens, and if you see here, I found the CNC from the attacker. This is a command and controller tool, right? So I find here this information. So if you see here in the end, where is the place that the attacker are executing this specifically attacking, basically is from Estonia in Europe. So if you see here, we found the CNC. So here I finished my presentation. So here's some books that this topic is very interesting. So you can investigate, you can learn mainly about that in those 4 books from PACT. It's very nice. And if you have any question, guys, so please let me know. It's a pleasure to be here to talk with you about this topic. And yeah, if you have any question, please let me know.